everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you once again what to look for in the night sky. This time we're talking about the week of March 28th, 2022. So what we're going to talk about here today is we're actually going to look at the bright stars of winter. And this is a reminder so we turn over to April this week. By the end of the week, it's the 1st of April. And we are definitely, for those of us in the Northern Hemisphere, definitely thinking about spring. It feels like springtime to us for sure here. And so this is a reminder that we associate certain groups of stars with certain seasons, but we are able to see these stars at other times. So as we go to spring, let's take one last look at the stars of winter. We've looked at all of these in recent videos, and well, not that recent, it depends what you call recent, but over the last 6 months or 7 months, we have had a look at all of these stars, but let's wave them goodbye. Let's bid them a farewell, so long for a little while here right now, and next fall we'll start to look at them again as they start to make an appearance in the morning sky. So this is the sky we're going to look at just after sunset. So you go outside, the first couple hours of dark is when this is really good. We've done a lot lately of looking at the morning sky, and I know the fact I get up at 4 o'clock every morning. I know everybody does not, and so it's good to have something here for those of you who would prefer to be out in the evening observing. And so let's look at these stars of winter. Let's actually draw this. So here's the sun. And we are orbiting this direction, let's say, in this diagram, which means we have prograde rotation. So we're also rotating this direction. We're orbiting this way, we're rotating this way. And so if you think about it, if the sun's right there, that's noon, and that's midnight. These are the stars that we associate. It's nighttime on this half of the Earth, and these are the stars that we associate with the season, whatever season it happens to be. Right now it's spring for us, so the stars that are sort of directly away from the sun, I often will think of as springtime stars for me here right now in the Northern Hemisphere. Leo, Virgo would be great examples of these stars that are out there, but pushing on toward the summer stars a little bit. But what happens is, as we rotate, that arrow points this way, and then this way, and then this way. Before we get to sunrise right here, we're actually looking more over this direction. And right after sunset, we were looking more over this direction. So we can see stars that are associated with the nearby seasons relatively well. So we can see the wintertime stars here just after sunset. Wintertime stars, springtime, summertime stars. So before sunrise, we're seeing the stars we most typically associate with the summertime here in the Northern Hemisphere, and just after sunset we were seeing the stars that we most typically associate with wintertime. That's what we're looking at right here. So that's the setup. That's what we got going on. These are big, bright stars. We've talked about this before, that the winter sky is really noted. What's special about the winter sky? There's not one thing that's special about the winter sky. There's lots of things that are special. But the one thing that we're going to talk about here is we've got these big, bright stars that really pop against the sky. So you've got Orion here with Rigel and Betelgeuse. There's your belt of Orion, and you've got the shoulders of Orion up here. And so there's Orion. Above Orion and to the north and to the west, we've got Aldebaran and Taurus the Bull. We keep cycling on up. We've got Capella and Auriga, and then we swing back down. So we do a loop up this direction and swing back down through the twin stars, Castor and Pollux. All fantastic bright stars to look at. We keep circling on around, and we come to Procyon and Canis Minor. And so this is a really big bright star, and we loop right on down to Sirius, the brightest star in all of the sky, in Canis Major. And so this is our tour of really bright stars. Start with Orion, recognize the belt of Orion, Rigel and Betelgeuse, and then circle up. Start moving. So you're watching the sky. It starts swinging up to the west and the north, circle through Aldebaran, up through Capella, and down through Castor and Pollux. Pretty red star right here that you'll notice. So you'll enjoy that red star. Capella's a nice yellow star, and then you'll swing back through the whitish-looking stars of Castor, Pollux, Procyon, and Sirius down this direction. Now, what's interesting, again, there's not one thing that's interesting. There's one of the things that's interesting that we want to think about here, Sirius, brightest star in all of the sky, certainly the brightest star in Canis Major. Procyon, very bright star, certainly the brightest star in Canis Minor. They both have white dwarf companions. So you have two really bright stars that have these evolved white dwarf companions. I don't think you can see them. It took a lot of work for people to be able to see them. If you have the technical ability and you want to go out and you try, what you want to do is to try to block the light from the primary star somehow. So you want to have some sort of block you can put in there so you're not overwhelming the faint companion with the luminosity, with the glow of these brighter stars. But I don't think it's probably worth the effort and the time to try to do that, because you're probably not going to be successful. But you go out and prove me wrong, that's fine. It's just interesting to know that we've got each of these have an evolved companion. And what a white dwarf star is. So in a white dwarf, most of the stars in the sky will become white dwarf stars at some point, like the sun. Anything smaller than about 8 times the mass of the sun, and actually a lot of stars I think that are bigger than about 8 times the mass of the sun can become white dwarf stars too, as they develop a stellar wind and really shed mass. They're blowing material off their outer layers toward the ends of their lives. They could switch over, and instead of becoming a supernova neutron star, they could become a planetary nebula white dwarf star. So what happens is this. Stars on the main sequence, most of the stars in the sky are contentedly fusing hydrogen into helium in their cores, releasing energy, and that's supporting the luminosity of the star. The luminosity is the star's radiating energy out into space. That radiation of energy out into space would cause the star to cool and cool and cool and just disappear if there weren't something supplying that energy. And what's supplying that energy is taking 4 hydrogen and turning it into a helium, a more complex process than that, but let's not worry about it, in the core of the star. When all that's gone in the core of the star, the fusion stops. We stop supporting that luminosity. The star does cool down, and it tends to contract a little bit. When things fall inward under the influence of gravity, they heat up. And that heating up allows the fusion to start again in a shell around the core of the star. This goes on, until finally you reach a stage where you become an asymptotic giant branch star. You reach a stage where you keep stuff falling inward, helium falling inward, for example, after you make it, heavier stuff falls, and it releases that gravitational potential energy. As you collapse inward, it heats up. So stuff falling inward heats up. So the cores of these stars are getting hotter and hotter and hotter, and that's a higher pressure, and that higher pressure is pushing the outer envelopes, the outer layers of the stars further and further out. And at some point, the star will actually be oscillating between a helium fusion shell and a hydrogen fusion shell. So you'll have a shell that's fusing hydrogen into helium around an inert core, and then you'll have a shell. Actually, you'll have an inner shell that's fusing helium into carbon and heavier things, and feeding that carbon down into the core, causing it to heat up and pushing that shell outward. That shell will shut off, and you'll get a hydrogen burning shell. So you'll toggle back and forth between a hydrogen burning shell and a helium burning shell, where you're getting all of this stuff, that these shells that are firing, they're turning on. It's not kind of like nuclear explosions. They're turning on explosively and turning off and pushing that outer layer further and further out until finally you lose gravitational control over that outer layer and puff it off out into space. And that's your planetary nebula. And what's left over is a white dwarf star. And that white dwarf star, there's a companion here and a companion here. So that's why we bring that up right now. Interesting to think about. Let's look on down at Canis Major before we lose it here. Again, we're looking at the first couple hours after it's dark. This is a great time to go out and look around. We've got, see if you can identify the other stars here. You've got Mirtsam over here, Wizen, and Adhara down here. Adhara is a fine double star. If you can dig that far south, that's way south for those of us who live as far north as I do. If you can dig that far south, you got 7 or 8 arc seconds separating these two stars, which is just about perfect for most small telescopes to observe. And there's a really nice color difference between these two stars. One of them looks pretty orange. Get out there and try to find that double star with your small telescope. The other thing you should look at with your small telescope is a couple of good open star clusters. If you draw a line from Procyon to Sirius like this, a little less than halfway up between the two, and just a little bit above that line is an open star cluster M50. So take a little bit of time and poke around with your telescope in there and see if you can find that open star cluster. And then just below Sirius and Off to the west a little bit is M41, another really fine open star cluster. So if you got a telescope and you're out there looking with your telescope, these are great star clusters to try to find, and try to find this double star. Try to observe this double star. Otherwise, just learn these stars and enjoy this pattern and enjoy this last eclipse of the winter stars as we head into spring and summer, and realize it's not going to be that long, and they're going to come back around, and we're going to see them in the evening sky instead of the morning sky. So, I mean, in the morning sky instead of the evening sky. I've been talking so long, I've lost track of what I'm doing here. So, right now we're seeing them in the evening sky. A few months from now, 5 months from now, let's say, we'll be able to start to pop them back out in the morning sky. Maybe 6 months from now, we've got a lot of daylight for us in the summertime up here in the north. So we have shorter nights. We don't see quite as much nighttime sky. So I think that's what we got. I feel like there was one more thing I was going to talk to you about, but I'm sure you're worn out. I'm worn out. We've gone through all of this stuff. So that's what we're looking at here right now. Good. Have a good week, everybody. Good luck with observing the sky. Hope you have clear skies, and we'll have something new for you to think about and to look at next week. Thanks.